device and an output device connected together to an I/O port. And so that's going to be bidirectional. So you can use this port as an output and you can use it as an input. What is the difference? It's a matter of configuration. Whatever you configured as an output is going to act as an output. Whatever you configured as an input is going to act as an input.
Right.
If you configure the entire port as an output for a particular application now, then maybe a few minutes later you can configure it as an input. You see what I mean? You can do whatever you want using the program.
I did not hear anything.
It depends on how you configure it.
Okay.
Here is typical. This is a microcontroller. This is port E. These are always inputs. Yeah, usually the A to D converter has a data ready at the end of conversion. This usually initiates an interrupt routine to take care of the reading process. The reading process is quite involved here. But the data direction register is going to be always having 0, 0 for the first two lines because this is input.
Right.
You can choose the entire port E as an input. Yeah, it's up to you. But it's mandatory that we should have bits 0 and 1 as inputs. You can choose the other bits, whatever you want, like bits 2 through 7. You can choose whatever you want. There is an important feature here that I would like to show you, and that's, in my opinion, the basic idea behind using the microprocessor or the ports. That's the main reason for the ports. Reading and writing data, controlling things, moving things. You see what I mean? You can move things mechanically by electronic control. The microcomputer is going to do all of this to you. How? These are a couple of examples. This page is very important, by the way. It's in the supplementary material. Suppose you want to read the location of the switch. You want to read if the switch is open or closed. Here is a switch. Here's the resistor connected to VDD. You know, you might use something similar to this in the interrupt experiment close to the end. Maybe the only hardware we're going to ask from you is have a resistor somewhere, you know. You have an old resistor somewhere.
Professor, I have a question. For the input-output port, can that be also called a network port? Or is that something else?
Can it be called what?
Network port.
Network what?
Network port?
No.
No, it's not the same thing?
No. I'm sure you must have heard this terminology in another course, but it's a different jargon.
Yeah, I heard it in EE310. Oh, okay.
Yeah, it's a different jargon. EE310 is a math course to me. It's a system course.
Basically, yeah.
System, signal and system. I taught something similar to it before. I know what it is talking about. It's talking about.
But it's not the same, huh?
No.
Okay.
No.
All right.
Look, I want to tell you something. If you see the word port in one course, it doesn't necessarily mean the word port in this course. You probably have seen port A and port B in feedback networks. Those who took 430 class with me or will take 430 class with me, you must have seen port A and port B. It's called two-port analysis. So port A is a box that has some circuits in it, but that's not what we're talking about here. What we're talking about here is a physical entity called port that holds data. You see? So the port in our context here is a physical entity that holds data, and this data could be outputted. In this case, it's called an output port. It could be inputted. In this case, it's called an input port.
Okay.
But that's different from the context in 310, different from the context in some other course. Now
Okay.
let's look at, let's look at this first example. A switch. By the way, nobody should get scared by seeing a switch. You're going to say, okay, where are we going to buy the switch? The stores are closed and all of this. You don't have to buy any switch in this course, in the lab. The switch is nothing but the closure of 2 points. If you hook this point to ground or you hook it to power supply, that's an action called switching. So it's by your choice. You could connect this point to ground. You could not connect it to ground. You don't connect anything to ground. Leave it connected to VDD. So in that sense, it's a switch. But you're not supposed to physically buy a switch to do any lab in this course. In this particular example in front of you, you know, the input port, this is an input port. Why? Because we want to read the position of this switch. If the switch is closed, the voltage here is going to be 0. If the switch is open, this point's going to be connected to the power supply, and the voltage here is going to be logic 1. So if we read here, we read that point. This is connected to the port. If you read 0 here by the input port, that means the switch is closed. If you read 1, that means the switch is open. And this data is going to go to the accumulator, of course. When reading the position of the switch means converting the mechanical setting here, or the mechanical position of the switch, into data into the accumulator. That's the action of reading in the language of microprocessors. So if you read 0, that means you are that means that the switch is closed, short-circuited. If you read 1, that means the switch is open, so it's connected to VDD. All right, so you can tell whether the switch is open or closed by the number that you read, whether it's logic 0 or logic 1. All right, so that's converting the mechanical situation into an electrical signal, sort of say, you know. The opposite is true here. We can use it for writing data, for controlling a mechanical position of the switch. So the first one on the top is under the category of data acquisition, but the one at the bottom is under the category of data of control. There is an acquisition and control here. So the top one is an acquisition. You're acquiring the location of the switch. You want to determine the location of the switch. Here, you're controlling the switch. If you output logic 1, for example, here to the switch, you're actually closing the switch. If you close the switch, that means this point is going to be grounded if you close the switch. So V output is going to go to 0 volt. But if you output